Hello everyone, and welcome to my second official video. The actual second video was just a conversation about me, but that's not important. Today I come to you with another fact about a place you may or may not have heard of. It's the deepest place on Earth. It is called the Marianas Trench. It's a big, well, it's not a little, it's a big trench close to the Philippines. So in this video I'm going to explain some things about it. So the first thing about the Marianas Trench is that it is on what is called a subductive fault line. And what that means is, say you have two tectonic plates here. You have one here going this way and one here going this way. This one and this one is a little bit denser than this one. What's going to happen is this one is going to sink. It's going to sink down into the mantle, and this one's just going to kind of float on top. And this is where the trench is, right there. So then, something that also happens along this fault line is there are also small islands that occur that are right next to the Marianas Trench, and that's due to the fact that when this plate sinks down, it actually pushes this plate up. This happens when you have tectonic plates that are very similar in density, and then actually something else happens that helps this out. So let's say this is a section of your tectonic plate right here. Oh. It's made up of a bunch of different minerals. So let's say that mineral A here, mineral A has a melting point of, or rather a boiling point, I meant to say boiling point, of, let's say, 450 degrees. So that is the point in which it gets hot enough for the liquid form of the rock to turn into a gas. But then let's say that mineral B here, right there, has a boiling point of, let's say, 275 degrees. So this temperature is a lot lower than this one, but the mantle is very, very hot. So then it can melt some of the. It will melt the heavier one. It will melt the ones with higher boiling points, but it will actually boil those with low boiling points. So what ends up happening is, as this one is sinking, you get a pool of magma, you get a pool of molten rock here that actually has little air bubbles of boiling rock, essentially. And what happens is, gases, if you no doubt know, are lighter than liquids. If you've ever had carbonated beverages, you'll notice that all the bubbles always float to the top. They don't just sink to the bottom or anything. So what happens is the bubbles start rising, and it takes the magma with it up into the other tectonic plate. So then not only do you have rising islands near the trench, you have volcanic islands, and that's what you have at the Marianas Trench. So here, this line here is the trench here, and then these dots along the trench, those are the islands that form from the fault line. And here's Guam right here. And then if you go, let's see, what direction would that be? That would be no. Well, if you go north, you'll go up and you'll be near Japan. If you go south, you'll have this island Papua New Guinea, I always pronounced it New Guinea, but it's pronounced Papua New Guinea, which is right above Australia. And if you go west, you're going to find the Philippines. And then if you go east, you're going to find the rest of the Pacific Ocean. So it's actually close to the coast. A little more than right in the middle. So then, how deep is this thing? Well, measurement showed it to be 36,070 feet below sea level. To put that into perspective, Mount Everest is 29,029 feet above sea level. So if you were to take all of Mount Everest, evened it out so that the area where it was at 0 feet above sea level, and you took all of that rock and you shoved it into a point on the Marianas Trench, 36,070 feet minus the 29,029 feet of Mount Everest, that you would still be 7,041 feet underwater, or 1.3 miles. You would be a little over a mile still below sea level. So, how was this depth measured? Well, actually, the Challenger Deep was measured with a rather cunning device made by the British. This is a British ocean depth measuring device, and what it is there's a hook here, there's a hook right here, and this is a cannonball with a hole drilled through the middle so this pole can pass through it. And then up here is the releasing mechanism, and when this outlying part right here hits the bottom of the ocean, so when it hits the bottom of the ocean, these teeth up here release the string and the cannonball falls off. Well, the rope that they used to drop it, the cannonball kind of acts like a weight. It pulls the whole system down to the bottom of the ocean, but once the cannonball drops off, the rope that it's attached to stops sinking, it floats back up to the surface, and that's how they knew they'd hit the bottom. So the deepest part of the Marianas Trench is called the Challenger Deep, and a common misconception about that is there was once a famous submarine that took a trip down there, and they often think it's named after the submarine. They thought the submarine was named the Challenger, but that is actually not true. The name from the Challenger Deep came from a British sailing ship, and the name of that British sailing ship was the Challenger, and it used this device to figure out how far down it was. So actually what they did was, this was connected to a huge long really super long cord, and because they knew the ocean was deep, they weren't idiots. They knew the ocean was real deep, so they just had this huge big long cord, and they marked it off at 100-foot intervals each, and then they just dropped the cannonball over, and when the cannonball fell off, and then when the cannonball fell off and all the rope floated back up to the surface, they measured how many 100 marks it had moved, how many 100 marks it had sank before the cannonball fell off, and that's how they determined how deep it was at that point. So they got to the Challenger Deep and they threw it off and just kept going and going and going, and they were waiting there for a really long time, and they were like, there's no way the ocean is this deep. Well, eventually it did reach the bottom, and that's where we got the measurement of a little over 39,000 feet. Now you're probably wondering, if the submarine was not named the Challenger, what was it? It was called the Trieste. And here it is, I spelled it out here. It's Trieste. I actually originally thought it was Trieste with a K, but it's not. It's Trieste with a T. ST. And something remarkable about that, which you probably heard of, which is why you probably associated the Marianas or the Challenger Deep with the submarine, is the fact that it took a trip into the Challenger Deep and it had a window 6 inches thick. See this rectangle? From here to here, that's 6 inches. See, this is my pencil. It's long. It is thicker than my pencil is long. It is actually about perfectly as thick as a pencil. So imagine a piece of glass as thick as this pencil is long. When they got down there, eventually the pressure was so great, because as you go down underwater, the pressure increases, because there's a lot of water on top of you, which, duh. But eventually, they got so far down that the pressure was so great, was too great, and the glass actually cracked. The glass, this 6-inch thick piece of glass cracked because of all the pressure. That is an immense amount of pressure. And just 5,000 feet can be lethal for a human, but that is 39,000 feet below sea level. So, we talked about a lot during this video. We talked about tectonic plates and subductive fault lines and a little bit of history behind it. But if there were any parts of this video that, if there is anything involved with the Marianas Trench that I did not include in this video, feel free to leave that in the comments below, and I will look into that, and I will maybe look into that and do another video some point later. But until then, that is all you need to know about the Marianas Trench. I'll see you guys next time.